nothing. But once it finishes running and the child process exits, you'll notice that the command runs. So it's kind of in a queue waiting to be ran, but the parent process is kind of frozen and can't do anything while the child process is executing. So I'm going to show you here in the process list what I'm talking about. If I type sleep 1000, this is going to tie up this terminal, so I'm going to open a second terminal. So I'm going to go to File, Open Tab. It's going to open a second tab. Now I'm going to run PS. You can use multiple different options with the PS command. I like to either use AUX or TACEF. TACEF I think is better because it will show you your parent process IDs, and that's what I'm kind of wanting to look at right now. So I'm going to do PS TACEF, and we're going to just pipe that to the less command so that we can see it more easily. I'm going to go down here and find that sleep command. There are a lot of processes on this system. So we got to find our bash shell and the sleep command that we just executed. So there's 14846. Let me cancel this. The $$ variable stores the actual PID of your current bash shell. So 14846 is the correct process. So let's run that sleep again. I'm going to run this command one more time. And I'm just going to say /sleep to kind of do a search for that. So here we can see it. There's the sleep command. And we can see in the second column, it has a PID of 1190. And its parent process in the second column here is 14846. That is our bash shell that we're running over here. So that process is currently in kind of a sleep state, waiting for a return of the child process sleep so that it can continue doing what it was doing. Now, and the reason why it does this here is because of the standard input, standard output. The standard input, standard output here for the bash shell is the terminal that we're in. And we can see what terminal that is if we look at the process list. This column right here tells you what terminal that command is running in. And we can see that this was actually running in PTS1. Now if we look over here, let's see what terminal this was. TTY /dev PTS1. But our bash command, or our bash shell, if we go up and find our bash shell, so let's do a /bash. So there it is, the 14846. It is also /dev /PTS1. So both commands cannot use the standard input from the terminal at the same time. So it basically pauses and waits for the child to finish so that it can then use it for standard input afterwards. So if you wanted to allow the sleep command to execute without that, you can background it. Backgrounding a process, you simply just put a space and then an ampersand on the end. And what that's going to do is it's going to execute it as a child process, but it's going to give that standard input back to the parent process so that we can continue typing and doing stuff with the parent process while the child process is still running. And so let's see how this works. When I run this command, it should tell me the PID for it. And you'll notice we get the command prompt back. So we can actually type commands in here and it will work. But if I do a PS, I'm just going to do a grep for 10247, we can see, here's our process, the sleep command, and we can see that its parent process is 14846, which is our bash shell. So it's currently running, and we can see it again. It's still running because it has to sleep for 1,000 seconds. but we can still type stuff and do things in our bash shell, so it kind of frees it up. Now, something else I want to show you here is that what you'll notice is this is currently running PID 10247. Now, if I close this terminal, which also had the bash shell, and look for a sleep command that's running, or a sleep process, there is no sleep process running. And this is because typically, depending on how the applications are written, but typically, if a parent process has child processes that are currently running, if the parent dies, the children will also die. There are some cases where when that happens, depending on how they're executed, where if a parent dies, the children will actually become adopted by PID 1 or System D. On other systems, it's actually called init. And when that happens, those processes are actually called orphans. That's how you refer to them. So when a child process that's running has a parent that actually gets killed or dies in the process list, it becomes an orphan and then gets adopted by PID 1 or System D in some cases. But in this case, what happens is when the parent dies, all the children underneath the parent also die. So I'll show you how you can avoid that if you wanted to. There's a command called nohup. And if we look at this, the description says run a command that's immune to hangups with output to a non-TTY. Part of the reason why the process exits when the parent does is because now it doesn't have that /dev PTS1 terminal that it's currently tied its standard input or standard output to, because we exited out of it. So it dies as well. Now when we run nohup, what it does is it will automatically execute the process and it will not be getting its input or output from the terminal anymore. Instead, it will create a temporary file on the disk where it will redirect all the output of the process into that file. That way there's no issues if we decide to exit out of this terminal or it receives some other sort of hang-up signal, it will not actually exit. So I'm going to type nohup sleep 1000 ampersand to put it in the background. So you can see that it says ignoring input and appending all output of that process to a file called nohup.out. And we can see that that file was created right here. This process has no output, but if a process did, that's where the output would go. Because again, if the input and output that was tied to that process was this terminal, then by exiting the terminal, it's going to hang up that signal or kill the signal or the process. So if I do a pstech-ef and I grep for sleep now, we can see that there is a sleep process running with a parent PID of 21137. And that's because if we echo $, the bash shell that's running in this terminal on /dev pts2, that terminal is actually, the PID is 29945. So we can see the parent process, the sleep process is 29945, and the process of this is 21137. A couple other things that we can look at if we just do a PS, some basics here. We'll do a pstech-ef, and I'll do a head, tech1. What that's going to do is it's just going to show me tech2, just the top two processes in the process list. So this is PID 1 or System D. We can see that the user ID that it's ran by is the user root. These up here are kind of the names for each one of the columns in the process list. The second column is PID 1. That is the PID of the process that's running. The PPID is the parent process ID, in this case 0, because remember what I said, every process has a parent except for PID 1, which is System D. Some of the other stuff we're not going to be too concerned about within this course. The other thing that is worth noting is the CMD. CMD basically just tells you what binary or what command was executed in order to start this process. And then we also have the CPU time. That basically is a representation of how many cycles or how much time has it actually spent executing individual instructions on the CPU since the boot boot time. And it doesn't take a lot of time to execute an instruction on the CPU. So unless the process is extremely process intensive, most of the time you'll notice that all processes have a CPU time of 0. Some of them have a little bit more, but most processes take micro or nanoseconds or even picoseconds to actually execute on the process, and so it doesn't show up because it only shows it in hours, minutes, and seconds. So those are some of the basic things you should understand and be able to interpret in the output of the PS command. Like I said before, I usually like to use PS Tech EF. There are a lot of options and ways you can use PS. In fact, there's 3 different types or styles of options. There are Unix options here, which must be preceded by a dash. There's BSD style options, which may be grouped and not used with a dash. And then, well, they must be grouped and not used with a dash. And then there's actually GNU long style options. And so the difference between those are, for instance, PS TAC AUX is a completely different command from PS space AUX. So you really have to go through and look at some of the options that are in the process or for the PS command and see what types of information you can derive from the processes. There's some examples and stuff in here, but like I said, the majority of the time, PS Tech EF will get the job done. So that's the command and the options for the PS command that I would use. Lastly, we want to take a look at some of the information related to processes here. If we do an ls of /proc /proc directory, you can see that there are tons of directories in here with just names of a number. And each one of these relates to an actual process. So for instance, echo $$. So our PID is 29945. If I do an lstech led on /proc /29945, we can see that there is a directory in /proc for the process of our bash shell that's actively and currently running right now. If I go into that directory, we can see that there's lots of different information in here. You do not need to understand what all this information is or what any of these files actually do. It's just good to be basically familiar with the fact that there is something called /proc, and you can look at a lot of the characteristics and files, and you can even look at the memory space and what's loaded into memory and all types of information about a process that's currently running on your system. For instance, the TAC EXE, that is actually a symbolic link. So if I do an lstech-l on EXE, you can see that that is actually, basically what that is that's telling you what binary on the system was loaded into memory to execute this process. And that's something that can be really useful, especially if you're trying to investigate a malicious process on the system. So you can see a process may be named one thing, but may have been loaded by a different binary. So you can find out exactly where the binary is on the disk for that particular process. You can also look at the CWD symbolic link, which is a current working directory of where that process is operating out of. And the reason why it does that, if you see if I do cd tilde, and I run /lstech-l /proc /29945 /cwd, It now says /home/student. The reason why the current working directory said /proc/29945 is because I'm currently in that process. That is my bash shell, and I CD'd into that directory. So you can see that there's information dynamically changing for that process in memory that is being reflected on disk. So this really brings to light the whole saying that the Linux operating system, on a Linux operating system, everything is a file. And it literally is. We can look at every aspect of a process just as if we were looking at files by looking into the /proc directory. We can also use the lsof command though on, I forget what PID we are. So lsof tacp on 29945. This is going to give us, there's a bunch of different options you can use with it to get different information, but this is going to give us some basic information here related to what open files it currently has, where its standard input or output is going. So we can see here that it's currently operating at a /home/student. We know that. We can see that it's using this user bin bash binary. The process also has all of these libraries that it loaded into memory in order to function. These libraries have different pieces of code that it needs in order to do what it needs to do. And then down here we have our standard input. Remember, under the FD column, which means file descriptor, we have 0, which is our standard input, 1, which is our standard output, and 2, which is our standard error. And if we look all the way to the right under the name column, we can see that all of those are going to /dev/pts/2. And if I do a TTY, I can see that that is my terminal screen that I'm in right now. And that is the basics of how you would use the lsof command. Play around with it some more, see what types of information you can get from a process, and just get familiar and comfortable with it. Hopefully this helps kind of demystify how the process executes and works on a Linux system, and how to be able to background a process if you need to in order to execute a process and then continue working within your shell so it doesn't tie up your shell, and that will allow you to get more work done at the same time.